Here's the frequency distribution that we looked at earlier. You recall the meaning of all these numbers. These are the frequencies times the x. 3 occurrences of 120 adds up to 360. 6 occurrences of 125 adds up to 750, and so on. When we add up all the actual numbers, we get 8,880. We've added up a total of 64 numbers, so our mean is approximately 140. I'm going to round this off to 140. Now we want to calculate the standard deviation here. First thing we need is our deviations. And then we're going to need the deviation squared. And then, since each of these represents something that occurs multiple times, we'll need f times the deviation squared, so that we can add up all our squared deviations. Then we'll be able to average them and calculate the standard deviation. Now the deviation here, and let's do that again. Deviation is just absolute value of x minus x bar. The square is x minus x bar squared. So this will be the frequency times the absolute value of x minus x bar squared. So let's calculate these numbers. If the mean is 140, it's actually closer to 141, but I'm going to keep the numbers as round as possible for this calculation. So the deviation here from 140, between 120 and 140, the difference is 20. 125 and 140, the difference is 15. 130, the difference will be 10. Then 5. 140 is the same as the standard, as the mean. And it should be pretty clear that our deviations are going to run like this. Now, those are easy numbers to square now. Our squared deviations are going to be 400, 225, 100, 25, 0, 25, 100, 225, and 400. Now, this deviation squared will occur for every one of these 120s, right? There are 3 of them, so we multiply 3 times 400, and we get 1200. And there are 625s, each with a deviation of 2 1/4. We add those up and we get 1500. There are 10 hundreds. Well, that's easy. That's 1,000. 16 25s isn't that difficult. That comes out 400, I believe. And 12 zeros, of course, is real easy. 825 should be 200. 600s is 600. 2 225s is 450. And 400. Okay? Then we can easily add these up. Again, the numbers are pretty cooperative. The only thing we got over here is a 1 5, and everything else is a 0, a single 5. And then we just add these numbers up: 2, 7, 11, 13, 19, 23, 27. And that's 3, 4, 5. Now, why did we add these up? Because we want the total of all the squared deviations. This is a total of all 60 of the squared deviations for all 64 occurrences. And this is, of course, the sum of the squared deviations. $57.50. Now we want the standard deviation, which is the square root of the mean of the squared deviations. We've got the sum of the squared deviations. The mean of the squared deviation is 5750 divided by 64, which looks to me like it's about 90. Maybe a little over 90. But let's just pretend it's 90. You can refine my arithmetic if you like. That's the mean of the squared deviation. The standard deviation for which your text uses S, is the square root of the mean of the squared deviations, which will be the square root of 90, which is going to be about 9.4. In notation, the mean squared deviation would be the sum of f times the absolute value of x minus x bar squared divided by, well, we could divide it out here, divided by n. Pretty sloppy notation, but hopefully you can make out what that means. And of course the standard deviation is the square root of that. So let me see if I can write that out to where it's halfway coherent. And I did something really stupid here. The square root just applies to the numerator. It wasn't stupid, it's just careless. It's getting a little late here. But we can repair that without too much trouble. And shouldn't have repaired that. That was right in the first place. Now I've got whiteout all over the place. The square root really does apply to this whole thing. So let's see if I can fix that. Okay, it all looks pretty horrible. And I apologize for that, but hopefully this will help you understand the notation as well as the process of calculation.